Good morning, students. Today I am going to discuss a new topic, which is potential energy of a system of charges. We already discussed what is meant by electric potential and what is meant by electric potential energy. And in the previous lectures, I discussed some details about electric potential, and we did some derivations also for a point charge and for a dipole. Now in this lecture I am going to discuss about potential energy. It is not about potential but about potential energy. You already know what is the difference between potential and potential energy. So in this lecture I am discussing about potential energy of a system of charges. What is meant by a system of charges? It means there are more than one charge present. So you need a system of charge. Okay, in this discussion we will discuss two different cases. First one, in the absence of external field. Second one, in an external field. Okay, so before going on to all those details, I will first discuss what is meant by this topic. You need a system. The system can be in any shape or configuration. So let us say you have three charges, Q1, Q2 and Q3. It is in the form of a triangle. This is a system. Or you have another system having four charges, Q1, Q2, Q3 and Q4, which is in the form of a rectangle, or if sides are same, it is square. So these are all systems. This is one system, this is another system. So in this lecture we are going to find what is the potential energy associated with this system or with this system or any other shape. Okay, so in this discussion first I will use a system of triangular shape of charges. Okay, and keep it in your mind, we are going to discuss in the absence of external field. In the next lecture I will discuss the second case, in an external field. Okay, so in this lecture I am discussing potential energy of a system of charges in the absence of external field. So for this you need a system of charges. Initially there are no charges present. All the charges are at infinity. Q1, Q2, Q3, Q4. So many charges are there at infinity. Infinity means far away. First thing is that you need to build a system. Then only you can find the potential energy associated with that system. So how to build a system? Let us consider you are building a triangular system. Okay, for that you need three charges. So let us consider the case of system of three charges. You are having three charges and you are making a system. For that it is in the absence of an external field. So in this region there is no external field. That is the case we are discussing. When the external field is absent, then there won't be any attractive or repulsive force exerted by any agency in this region. Okay, external field is able to exert attractive or repulsive force on other charges, but here external field is not there, so that there won't be any attractive or repulsive force in this region. So first thing is that you will move q1 from here to here, then you will move q2 from here to here, then you will move q3 from here to here, then you will get that system. Then you can find the amount of potential energy associated with that system. So I am moving q1 from infinity to this point, let it be A. In this process I don't need to do any work. Why? Because you can see there is no external field. That means there is no repulsive force exerted by any agency at this region. So there won't be any repulsive force acting on q1 if you move q1 from infinity to this point. When there is no repulsive force, it is very easy to move q1 from here to here. So you can easily move q1 from here to here. It is a very easy process and you don't need any amount of work done. Okay. So the amount of work done in this process is W1, that is equal to 0, because it is in the absence of an external field and there is no other charges present. So work done is 0. Now you are moving q2 from infinity to this point. This is B, which is at a distance of, let us say this is R1 2. I am using a notation R12. It means distance from q1 to q2 is R12. Okay, just for clarity I am using two digits 1 and 2. The distance between 1 and 2, that is the meaning. Okay, so what is the work done in this process? Is it again 0? As you can see, it is not 0, because even though there is no external field, now you can see when you move q2 from infinity to this point B, there is already a charge q1 at A. This q1 can exert a repulsive force on q2. So already q1 is here, you are moving q2 from here to here, but this q1 will repel your q2. So it is not easy to move q2 from here to here. You need to overcome this repulsive force. That means you need to do some work in this process. It is not an easy process. Okay, so you need to do some work on it. Work done is not 0. Hence we can say that there is some amount of work done by you to move q2 from infinity to this point B. What is that work done? For that you already know potential equation V is equal to W by Q. From this you will get W is equal to Q into V. What is Q here? Q is the charge you are moving. And what is V here? Potential at the point where you are moving this charge. So Q is the charge you are moving and V is the potential at the point where you are moving this charge Q. So in this case, which is the charge you are moving? You are moving Q2 and it is moving to a point B. Potential at that point is VB. Now you can find VB. What is VB? You already know who is creating potential at B. Actually Q1 is creating potential at B. Initially Q2 is here, so only Q1 is there. Q1 is creating a potential at B, and in that potential you are bringing Q2. So Q1 is creating potential. Q1 is a point charge. Potential due to a point charge at B. You know the expression. It is 1 by 4 pi epsilon 0 charge who is creating potential Q1, and what is the distance from charge to that point? It is R12. So this is the potential equation. Hence the amount of work done is given by W2 is equal to Q2 into VB. What is VB? 1 by 4 pi epsilon 0 Q1 by R12. 1 by 4 pi epsilon 0 Q1 by R12. Now you got 2 charges, but your system is having 3 charges. So next you will bring the third charge Q3 from here to here. So I am bringing Q3 at this point, which is C. When you bring Q3 to C, it is again not an easy process, because already there are 2 charges, Q1 and Q2. Both these charges will exert a potential at C. Q1 will exert a repulsive force at C, Q2 will exert a repulsive force at C. You are bringing Q3 to C. So Q3 will experience repulsive force from Q1 as well as from Q2. And you can say that there will be potential at C due to Q1 as well as due to Q2. So your charge Q3, if you are moving from infinity to that point C, you need to do some work. What is the amount of work done? It is W3. W3 means it is again W is equal to QV. So you are moving Q. Which charge you are moving? Q3. And you are moving it to C. VC. But at C there will be potential due to 2 charges, due to Q1 as well as due to Q2. So Q1 is at A. So potential at C due to Q1, let it be VCA. That means potential at C due to Q1. Q1 is at A, so I am using CA plus. There will be again Q3 VCB, because you can see this Q2 will also produce a potential at C, and you are moving Q2 to C. So there will be potential due to Q1 as well as due to Q2. Potential due to Q1 is VCA. Potential due to Q2 is VCB. Hence there will be sum of work done, Q3 into VCA plus Q3 into VCB. Now what is VCA? VCA, as you can see, it is again potential at C due to Q1. Q1 is a point charge. So due to a point charge, let us consider this distance. Let us consider it as R13, because between 1 and 3. And this distance, let us consider that it is R23, between 2 and 3. Now what is VCA? It is the potential due to a point charge, 1 by 4 pi epsilon 0. Which charge is producing potential at that point? Q1. And what is the distance? R13. Now what is VBC or VCB is equal to 1 by 4 pi epsilon 0, which is the charge producing potential at C, that is Q2, divided by what is the distance, that is R23. So you got VCA and VCB. Okay, now W3 is equal to Q3 into what is VCA, 1 by 4 pi epsilon 0 Q1 by R13 plus Q3 into what is VCB, 1 by 4 pi epsilon 0 Q2 by R23. So you got W3. So you got the system of charges, isn't it? You are having the system of charges. What is the total amount of work done in this process? You build a system of 3 charges, and how much work you did in that process? It is nothing but W is equal to W1 plus W2 plus W3. This W1 is 0. What is W2? W2 is 1 by 4 pi epsilon 0. You can see here 1 by 4 pi epsilon 0 Q1 Q2 by R12. There is a Q2 multiplied by another term. So if you take it together, it will be 1 by 4 pi epsilon 0 Q1 q2 by r12, q1 q2 by r12. And what is w3? It is here. There will be two terms. Okay, so net work done in this total process is 1 by 4 pi epsilon 0 q1 by r12 plus the other two terms q3 into 1 by 4 pi epsilon 0 q1 by r13, which is nothing but 1 by 4 pi epsilon 0 q1 q3 by r13. 1 by 4 pi epsilon 0. Oh, there is a term q2 here, q1 q3 by r13 plus there is one more term, that is 1 by 4 pi epsilon 0 q2 q3 by r23. 1 by 4 pi epsilon 0 q2 q3 by r23. So this is w2, this is w3, and w1 is 0. Hence net work done is w is equal to w1 plus w2 plus w3. This is in the case of when external field is absent. There were no external field present. Then you can solve the problem in this way. Okay. So in the next lecture, I will discuss the case when there is an external field.